Okay, so probably all of us know that we have at least two of different runner layouts in our injection molds. The oldest one, I think, is the older one. Perhaps not the oldest, but the older one from the H type is so-called fishbone layout. And what is typical about this fishbone layout is that the flow path from the sprue to different cavities are not equal. The length is different. We can see clearly here that the length of the first cavity is much shorter than the length of the flow path to the last cavity, and that's of course the reason of mold filling imbalance if we are not making any kind of so-called rheologically balanced runners, so without changing the diameters of the runners, of the gates, and so on. And the other one is of course this H-type runner, which has been developed to have fully geometrically balanced molds and to achieve the exact length, the equal lengths of the flow path to the different cavities. The exact equality, I would say, of the length. And the first layout, the fishbone, like I said, is a obviously imbalanced one, because if we make a shorter sample, we receive such a pattern. So the inner cavities are always fill always faster than the outer ones, and it is and it was possible to simulate in Moldix3D and in other softwares from I think almost the early beginning of the technology, because like we can see from the logo here, this is a result, a picture from a quite I would say old version of Moldix3D. I think it has a 10 years old, at least the picture here on the left. And of course, it is 2.5D mesh here in this specific model. But we have our H-type runners, our geometrically balanced molds, and because they are balanced, the filling should be also balanced. And as we can see, probably all of us have already seen from different